A lot of my students are working on Pythagoras' theorem at the moment, so I thought it would be a great idea to shoot a quick video to detail the 4 key aspects of mastering Pythagoras' theorem. So what are these 4 aspects? First, finding the length of the hypotenuse, which we'll go into a little bit more detail soon. Finding the length of the shorter side. Using Pythagoras' theorem to find and prove whether triangles are right-angled triangles, and finally being able to solve worded problems that require you to draw your own right-angled triangle and using Pythagoras' theorem to find the answer. So let's begin with number 1 here, finding the length of the hypotenuse. Now, what is the hypotenuse? Great question. The hypotenuse is a fancy word for saying the longest side of a triangle, alrighty? And if you're unsure of which side is the longest, okay, the trick you use is it's always the side that is opposite the right angle, okay? So the right angle will be the largest angle in a right-angled triangle, and the largest angle is always opposite the longest side. So this here is going to be your hypotenuse. And what you may have noticed is I've denoted that as C, okay? And in this formula, Pythagoras' theorem, C always stands for the hypotenuse. So let's go into what Pythagoras' theorem is. C squared equals A squared plus B squared. Now we've already seen that the C here is the hypotenuse, alrighty? So the A and B are what we call the shorter sides of the triangle. So this here would be A, and this side here would be B, alrighty? So Pythagoras' theorem is a nice little equation that will always help us find the lengths of different sides of a right-angled triangle. So let's try a question and start stepping through these 4 steps, these 4 different types of questions to help you master Pythagoras. So, when you're trying to find the hypotenuse of a question, these letters will be replaced with numbers. Alrighty, so let's use the example of not knowing the hypotenuse, this length being 4 centimeters and this length here being 3 centimeters. And again, we're trying to solve to find how long C is. So the first thing that we always do is we write out our formula. So C squared equals A squared plus B squared. The next step is we're going to substitute in the values that we've been given. We have no idea what our hypotenuse is yet, so we're going to leave it as C squared. Alrighty, we know our A is 3 centimeters and our B is 4 centimeters there. Now we're going to solve this right-hand side. So 3 squared, which is 3 times 3, is going to give us 9, and 4 squared, or 4 times 4, is going to give us 16. 9 plus 16 there is going to give us 25. And to get rid of a square root and find out what C is by itself, we do the opposite of squaring, which is square rooting. So square root both sides and you get C equals 5. And as always, it's really important to put in our units because we are finding a length there. Now, what's super cool about Pythagoras is you can actually do what I like to call a logic test. So in an exam, teachers aren't going to give you the answers. So you've got to come up with a few tricks to figure out, are you on the right path or is your answer completely wrong? So at the beginning, we decided that the hypotenuse was the longest side. So our logic test is the answer we found the biggest number, the longest side? 3 centimeters, 4 centimeters, 5 centimeters, it does fit the logic test of being the longest side, alrighty? And that's the process that you will use to find the hypotenuse for any Pythagoras question. The only thing now will be, you'll have different numbers you've got to put in. Alright, let's try number 2 now. Number 2 on our list was finding the length of a shorter side. So in this instance, they've actually given us the length of the hypotenuse. You use the same formula, but there's one extra step involved. So let's add some new units in here. Alrighty, let's say that we've been given this length as 10 centimeters, alright, the hypotenuse. We've been given this length here as 8 centimeters, and we are trying to find this shorter side here, alrighty? So, same process as before, let's write Pythagoras' theorem. Okay, let's sub in what we know. In this case, we do know that our C is 10, so we're going to write 10 squared equals A. We have no idea what our A is, so I'm going to just leave it as A squared. And your B here is 8, so you're going to write 8 squared. Now, let's figure out what these numbers are going to be. 10 squared, or 10 times 10 is going to be 100. We're going to leave the a squared, and 8 times 8 is 64. Now, this is a little bit of linear equations. We're trying to get the a by itself, so we minus 64 from both sides. That'll cross this component off, and we're left with 36 equals a squared. So this red step is the only additional step that you have to do, all right, compared to when you're finding the hypotenuse. And what you'll see is the ending steps here are quite similar. So we're going to square root both sides, okay, and we're going to get a equals 6 centimeters. Alrighty, always remembering to put in those units. And again, doing that logic test. If this is 10 centimeters and it has to be the longest side, 6 is definitely shorter than 8, so I'm happy with that. It makes logical sense for 6 centimeters to be the correct answer. Alrighty, again, questions like this may change the numbers. The process will be exactly the same. What is the third type of question you could see in an exam when it comes to Pythagoras' theorem? What might happen is they will give you 3 numbers and you need to see if whether or not the triangle is or isn't a right angle triangle. So let's get rid of all these lines and let's get rid of this little symbol here which shows right angle triangles, because we quite frankly don't know if the values on the triangle are going to make it a right angle or not. All right, and we never judge based on how the triangle looks. We always have to solve it. So let's say, for example, that we've been given the number 7 centimeters here. We've been told that this length here is 5 centimeters, and we've been given this length as 9 centimeters. So what do? Same steps as before. The first thing we do is we write out our formula. Next thing we do, sub in the values that we have been given. So our hypotenuse is 9 centimeters, okay, always the longest, and we're going to square that amount. Your A, 5 centimeters squared, plus your B, which is 7 centimeters squared. 9 squared, or 9 times 9, is going to give us 81, okay. 5 squared is going to give us 5 times 5, which is 25. Plus 7 squared, 7 times 7, 49. Now you're probably thinking there's no variable, there's no unknown to solve for. When you're trying to prove whether or not a triangle is right angled, you're simply solving both sides and trying to see whether both sides are equal to each other. If both sides are equal to each other, it satisfies Pythagoras' theorem and the triangle is a right angled triangle. If it doesn't and both sides don't turn out to be equal to each other, Pythagoras' theorem has failed and we're not looking at a right angled triangle. So let's finish off this question and see. We've got 81 on this side and then we have 25 plus 49, okay? So that's going to be 74. Now, 81 does definitely not equal 74, so we write therefore, which can be denoted by 3 dots like that. Therefore, the triangle above okay, the triangle above is not a right angled triangle. We'll cheat and just draw a triangle like that. Alrighty? Now, that's how you use Pythagoras' theorem for the third component there. Okay? Again, if you had done these steps and the two sides had balanced out, Pythagoras' theorem would work and it would be correct. Alrighty. Now, the fourth thing that I've written on the board was using Pythagoras' theorem to solve worded problems, okay? These are very detailed, they can be very different, so I recommend attempting these questions, definitely drawing a diagram, okay? Trying to attempt a Pythagoras question without drawing a diagram is making your life super difficult, and if you have any questions, bring it to your tutor, see how they solve it, and then hopefully next time you attempt the question, it's a little bit easier, okay? Thank you, everyone.